Welcome to this video on taking an ellipse that we have pictured and creating the set of parametric equations that would graph the ellipse. So we're going to go through this single problem together. First of all, the very first item we can do is determine the center point of our ellipse. It would have to have the same x-coordinate as the top point, so that'll be 5, and it'll have to have the same y-coordinate as this far right point, which would be a -2. Now we could fill in the blanks for the other points, but I don't know that that's particularly needed right at the moment. So what we would see is if we were writing this equation out in our typical form, the center point would yield x minus 5 quantity squared plus y plus 2 the quantity squared. We're going to have an equals 1, and we would have to get our denominators. The denominator under x is going to be determined by this right here. And from 5 to 8 would be 3, so that's going to be a 9. The value under the y term would be determined from this right here. This is 9, so 9 squared would be 81. And this ellipse is not necessarily drawn to scale. It's actually a vertical ellipse, and it looks more horizontal. Please make sure you base things off numbers rather than the appearance if it's not drawn to scale. And now that we have this equation, we can kind of turn our attention to how the parametric form is going to look. So we would have had x minus 5 all over 3, the quantity squared, had to equal either sine or cosine, and they could have been plus or minus being squared. Because remember when we developed this, we had sine squared plus cosine squared equaled 1. So the other of the two would have to be plus or minus either sine or cosine, that's to be determined, and it would be y plus 2 all over 9, the quantity squared. But now to think about this, let's get rid of the squares here because we don't really need the squares. So we're going to have x minus 5 over 3 is equal to plus or minus sine or cosine, which means that x is going to be equal to a plus. It means x is going to be equal to a plus or minus, we have to determine that, 3, either sine or cosine, to be determined, plus 5. And it would also mean that y is going to be equal to a plus or minus 9, either sine or cosine, to be determined, minus 2. Now how do we determine this? Well, we have to focus back at the point formed by t equals 0. In this case, t equals 0 is formed by 8 comma -2. Look at the x and the y equations. Y has a minus 2 in it. So if the term that we put in these parentheses is equal to 0 when t is equal to 0, that's exactly where we want to be for the y coordinate. Well, here's the scoop. Sine of t is equal to 0 when t is equal to 0. So if we put sine of t here, at t equals 0, we're going to get the y coordinate we want. On the other hand, that means cosine of t is going to have to come up into the top equation because one needs to be sine and one needs to be cosine in order to get sine squared plus cosine squared is equal to 1. So now that we put cosine here, remember that cosine of t is equal to 1 when t is equal to 0 because cosine of 0 is 1. So as we plug this in, cosine of t is equal to 1 when t is equal to 0. We'd have two options. X is either going to be 3 plus 5 or -3 plus 5, depending on whether we go with the plus or the minus. On one hand it could be 8, on the other hand it could be 2. We want it to be 8 because the x coordinate at the point where t equals 0 is 8. So the negative option is gone. We know it's going to be a positive, and we don't need to write the positive then. That's how it would look. How about y? We'll look back at the picture on the screen. From this point, it goes down as we go. Now sine of t is positive as t is 0 but a little bit bigger than 0. Sine of t is positive. So the only way that we're going to get this going down initially is if we have the minus option in front. So here would be the set of parametric equations for the ellipse that we have pictured. it would be x equals 3 cosine of t plus 5, and y is equal to negative 9 times the sine of t minus 2. So as you are going through and doing this type of problem, first and foremost, form the typical equation we would have for the ellipse. From there, manipulate how the x and the y individually need to look, with leaving a little bit of a blank to fill in whether it's going to be sine or cosine involved for x and involved for y. And then what you need to do is look at that point where t equals 0, determine, oh, which one of those two numbers is already there. That's where you're going to put sine. And then put cosine in the other place and make sure that you've analyzed correctly whether the coefficients are going to be positive or negative.